Hi, everyone. I'm Benji Lampel. I'm an airflow engineering advocate here at Astronomer. I'm filling in for Viraj, our field CTO, who's out today. And we have presenting today Kenton Danis, our lead developer advocate, who's going to talk us through an example of the load file function in our Python SDK. A little bit about the Live with Astronomers in general. It's a bi-weekly series of short real-time online sessions for data pipeline authors hosted by us, astronomers, resident airflow experts. Our topics range everywhere from featuring highlights in Airflow to DAG authoring how-tos to interviews with developers of Airflow. And all of our sessions will include a Q&A with the audience. So feel free to leave questions as we go through the live here with that Q&A chat feature, which is different than the chat bar in Zoom. There's one that specifically says Q&A. If you could please leave the questions in there, just helps me manage what's been asked and what's been answered. So I don't miss any questions for you. And yeah, we're just here to help get the most out of your Airflow experience. So without further ado, Kenton, please take it away.
Awesome. Thanks, Benji. Yeah, so as Benji said, we're going to focus today on the new Astro Python SDK, which is a newly released load file function. Just as a bit of housekeeping, this is being recorded, so you will receive a recording afterwards along with some resources that I'm going to detail at the end so that you can use this yourself. We won't go through too many slides today because as Benji said, we keep these very developer focused, so I'm going to jump into the code really quickly here. But just to give everybody some context on the Astro Python SDKs, we're going to talk about the load file function, which is part of it. But if you're not familiar with the SDK, we just recently had the GA release of the SDK a couple of weeks ago. We're super excited about it. It is an open source Python package that Astronomer maintains and develops. It provides you with tools and functions to kind of improve your DAG authoring experience. So it's designed to be easier to use, especially for folks who don't have as much Python experience or certainly don't have as much Airflow experience. And it's designed to allow you to kind of move, or I should say, write your DAGs based on how you want to move your data around. So it's going to simplify the data transformation process between different environments. And again, just make it a much simpler experience than kind of using traditional Airflow operators. So with that, you can imagine based on this description that there are lots of uses for this tool, but a pretty frequent one would be like an ETL or ELT type pattern. So that's kind of what we're going to talk about today. And with that, I'm going to jump right into an example DAG. So actually, I'm going to hop over to code editor here and talk about how you can get started with load file. So the load file function is going to do exactly what you would think it's going to do. It's going to take data from some sort of source that you have and send it into a destination. So that might be moving it from like a file in your local file system into Snowflake or something like that. We'll go through all of the different options. But to get started with load file, the first thing you have to do is make sure you install the Astro Python SDK. You can add it to your Airflow environment just like you would any other provider package. So it is a separate Python package, but again, it's fully open source. You can add it here. It's this Astro SDK Python. Again, version 1.0.2, I think, is the most recent. And that's going to give you access to all of the functions within the SDK package. Over to look at load file specifically. To get started with it, you can import it. So from astro.sql, import load file. You're also going to want these supporting functions, so file and table. We will talk about what both of those do in just a second. And again, no worries about this down. We will send this out afterwards, so you'll have access to this DAG again to get started with it. Once you have that imported, one of the great things about the SDK is its implementation is agnostic in terms of the systems that you're working with. So if you're used to Airflow traditional operators, you might know that there are operators to do sort of load load data functions, for example, like an S3 to Snowflake operator, or a GCS to BigQuery operator. One of the downsides of those operators is they're highly specific to the source and the destination systems, which means one, a thing has to exist for the combination that you're looking for. And two, you have to learn a new operator for each combination of systems that you're dealing with. One of the benefits of load file is that it's going to work exactly the same, regardless of where your data is coming from and where it's going to. So the parameters are going to be the same, super easy to learn and implement. The main things that you're going to do are point it to the file that you're going to load, and then tell it where it's going. You have some other parameters available to you that we'll go over, but that's really the basics of it. With load file, I have 3 tasks set up here to kind of show different implementations of it. This first one is going to load tasks into Snowflake. Again, I provide it with an input file. This is where you're going to use that file function. And then within that file function, all you have to do is specify a path to your data. Again, this is going to work the same regardless of what source system you're using. I happen to be using S3 in this case. And all I have to do is provide it that S3 file path and then a connection ID. You can then tell the load file function where it's going. So you do that by specifying an output table parameter. Again, you're going to use that table function that we imported for this. Again, this is going to be exactly the same whether you're working with Snowflake or BigQuery. I'm going to show later what a list of all of the supported databases, but you can give your output table a name and then specify the connection ID. So in my case, I'm going to Snowflake. If I were going to change this from GCS to BigQuery, say, all I would have to do is come in and change these connection IDs. Obviously, this path would change a little bit if this file lived in GCS, but the overall structure of the operator would remain the same. Again, you have some additional parameters available to you. So if exists is one of those, that's going to say if the table that I specified that I want to load data into, what happens if it's already there in my database. So you have some control over whether you want to, append data to an existing table, whether you want to create a new one, things like that. You can also load data directly into a data frame. So what you might want to do this if you're moving right on to a transformation step within the same DAG. So if you're doing an ETL pattern instead of an ELT pattern, to do that, all you have to do is not specify an output table. So in this case, I have the same input file parameter, but I just don't specify anywhere for it to go. And the SDK is going to say, okay, that means you want to keep it locally within local storage. So that's going to save it to a data frame. You can also load data from an API. So it doesn't necessarily have to be exactly a file. So in this particular case, we're using GitHub's API to access a file that's stored in GitHub. Again, nothing's really changing with how we've implemented this operator. It's just that the path to the file is that API path. And again, then I specify an output here. So super easy to use. If I hop back over to Airflow, look at this example SDK DAG, we'll see in the graph, these functions are going to translate into tasks in your DAG, just like any other traditional operator. So I have my load from API, load to Snowflake, and my load to data frame. You'll notice here that the load to data frame has failed in this case. So I just ran this a minute ago. And if I look at the log, I see an error here on a legal load to database exception. And it says, failing this task because you do not have a custom backend set up. So obviously, in this particular case, if you're loading to a data frame, you might be aware that storing large amounts of data in XCOM, so should back up. Loading into a data frame means you have to store that data frame locally, or I should say you have to store it somewhere within your Airflow environment. The default is going to be for Airflow to try and store that into XCOM. This is going to fail because you know that storing large amounts of data in XCOM is not best practice, and it can mess up your Airflow metadata database. So this is going to fail to give you a warning that says, hey, you probably shouldn't do this. You probably want to set up a custom XCOM backend, and then we link to a guide we have on how to do that. So highly recommend that if you're going to go that route for using this operator. If you really truly do want to store them in XCOM, maybe your data is really small and you just don't want to deal with the backend and you're willing to manage those risks, you can set this environment variable to override that behavior. But again, we have set up all of these functions to try and set you up for success when using them. So, and try and make sure that, you know, things like this don't kind of cause you problems down the road. Otherwise, that's pretty much it for implementing the load file task. So again, super straightforward there. Currently, these are the source systems and file types, destination systems that are supported. So you can have file types in any of these formats. You can load files from S3, GCS, or a local file system, and you can send them to one of these databases. So anything within these systems, again, you're not going to have to implement anything specific within the operator other than the connection. Our team at Astronomer is working on expanding the list of supported file stores and supported databases. So this list will grow in the future. Definitely watch out for expansions there if the system you want to use, if you don't see it there. And if there's one in particular that you're very interested in, you want to try out this feature, definitely drop us a note because we always love to hear that feedback.
So Kenton, we actually have one question that'll be really relevant to this slide, which is, does the load file use pandas explicitly, or can it be switched to things like Spark, etc., in the case of loading to a data frame?
That's a great question. So loading to a data frame, it is going to use pandas. There is not Spark support currently built in, but that is something that you've definitely looked at. And to be honest, I'm not sure where it is on the roadmap. But again, if that's something you're really interested in, definitely drop us a note because we're interested in hearing that feedback. But for now, it's just using pandas. Good question. Yeah. That brings me to kind of my last slide here. And again, don't worry about copying these links. We will send this out to everybody who registered afterwards. But some additional resources here. We did do a full-length webinar on the full Astro Python SDK, so not just the load file function. So if you're interested in learning more about this tool, feel free to come back and watch that. They will also talk a little bit about future work in there, as well as some other kind of docs and guides on how to implement this. So if you're looking for kind of extra guidance, we've got you covered there. And with that, for anybody who joined us live, if there are any other questions, we're happy to answer those now.
Yeah, we have one more question. To confirm, how does the load file function load to a database? Does it use the database explicit commands?
Yeah, that's a great question. So the short answer is yes, but all of that is going to happen under the hood. So the great thing about that is you don't really have to worry about how that is implemented. The SDK is going to take care of it under the hood. So while the commands for loading to Snowflake might be different than the commands for loading to like BigQuery, the SDK takes care of all of that. The one other thing I'll note here is I don't have an example that shows it, but if it is available for the combination of source file system and destination database, the load file function by default will use native transfer support if that is available, which is just going to speed everything up a lot. So for like this S3 to Snowflake example, Snowflake does have native transfer support for that. So that is a feature that is documented in the read the docs that I have linked in this slide. So if you want to learn more kind of about how that works under the hood and whether or not it defaults to on, but you can turn it off, which is relevant in some situations.
We have one more question. What are the backend custom XCOM databases that are supported. I believe that was all on the load file slide you were showing earlier.
Yeah, so we don't talk about, so the short answer is anything that you can use as a custom XCOM backend in Airflow is going to be fine here. So that's more on the Airflow side than it is on the SDK side. Yeah, so I would refer you to the guide on implementing a custom XCOM backend for that. Good question.
Okay, it looks like we don't have any more questions. So Kenton, unless you have anything else to say to wrap it up.
Awesome. Well, I will just note that again, we're super excited about this new Python package, and development is ongoing. We will also have a couple of other of these shorter sessions on other functions within the SDK coming up. So if you're interested in what you do after your data is loaded, definitely make sure to sign up for those. And yeah, always feel free to drop us a note if you have any questions. This is an open source project, so very much happy for any feedback. But yeah, with that, thanks everybody for joining us, and we hope you have a great rest of your day.